Eric Burgess here, and we have been told to simplify secant theta minus 1, this quantity, times the quantity secant theta plus 1. So looking at this looks oddly specific. If we do the special factoring of a squared minus b squared, we'll get the same thing as a minus b times a plus b. And recall that this arises because the a squareds get multiplied, and at the end, we get the b squareds. So we get b times b. That's going to be minus b squared. But in the middle, we're going to get a minus ab from this one and a positive ab from this one, and they're going to cancel out. So it winds up being that when we have a form that's got a minus in one and a plus in another, we can rewrite that form using a special factor property. So we could say that this thing up here is actually just the thing secant squared theta minus 1. Now, looking at this, a Pythagorean identity should come to your mind. And if it doesn't, it's okay. There is a way to quickly derive it. I always remember the default identity, secant squared theta plus cosine squared theta equals 1. And in this case, we want a secant squared. So that's when we have 1 over cosine, right? So if we divide by cosine squared to everything, cosine squared, and I should be writing thetas, but I'm just doing this really quickly for demonstration. We're going to get right here, this is a tangent squared, this is a 1, this is a plus, and this is a secant squared. So this looks very similar to this. The only thing we're missing here is we need a minus 1. So if we subtract 1 to both sides, we'll get tangent squared, and I'll write a theta here at the end. If you're doing this for your homework or a test or whatever, you should write thetas throughout. But sometimes it's just so much extra writing, so I get a little lazy. Don't do that. And we're going to get secant squared theta minus 1 is equal to tangent squared theta. This is a little side proof too, so I would erase this anyways. So we see that this must be tangent squared theta. If you can't remember, just use your basic identity and just simply derive it. Just ask yourself, what do I need to do to get a secant squared out of this, and then do that. And in this case, we saw we needed to divide the 1 by cosine squared. That would give us a secant squared. So this is equal to tangent squared theta. Easy as that. And depending on your professor, if it wants it just in the simplest terms, I personally think this is the simplest. Some professors may require you to write it in terms of sines and cosines. So you may see the answer written as sine squared theta divided by cosine squared theta, just because they want you to be in the habit of, I guess, going back to sines and cosines. But there you go. That is how you can do this problem. And if you can't remember the identities just from looking at it, it doesn't take that long to really quickly derive these. And this is something I do pretty regularly just so that I don't make mistakes. If you have any questions, let me know. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.